All right. So for number 2 on our notes, we have a charge Q, and it's fired through a small hole in a positive plate of a capacitor, as shown. So for the first one, we want to answer if Q is a positive charge, so we'll say Q equals some positive charge, does it speed up or slow down inside the capacitor? So we're going to justify our choice twice. First, using the concept of force, and second, using the concept of energy. So for force, we have the repulsive force of the positively charged plate and the attractive force of the negative charge. So that's what I'm going to write down. So positive plate repels and negative plate attracts to the left, or to the right, sorry, to the right, speeding up the charge, the positive charge. Okay, so it already has a velocity to the right, so it's going to get faster and faster to the right. So for energy, we can still think about this hill, but when we're really close to the positive plate, we have a lot of potential energy, and that means that we will be getting faster and faster as we roll down our electric hill. So, or sorry, yeah, that's right. If the charge is negative, it's going to flip around. So when close to the positive plate, we have a lot of potential energy, which is converted to kinetic energy, 2K. Now I could talk about the same thing with the negatively charged plate. Because we are far away from the negatively charged plate, we have potential energy there that is going to be converted into K. All right, let's do the next one. So now Q is going to be a negative charge. So what are we going to do for number 1 here, right? We know that it's going to slow down, right? It's the opposite, but why? So when we're dealing with force, we have the opposite forces. So we have the positively charged plate is going to attract, and the negative plate repels to the left. Slowing the charge. Cool. What about number 2? Right, what about energy? Well, now that we flipped our charge, we're now kind of rolling up the hill. So we actually have the maximum potential energy, or sorry, we have the least amount of potential energy when we are near the positively charged plate. So we have the least amount of potential energy when close to the positive plate. And gain potential energy as we move to the rightwards, losing kinetic energy and therefore velocity. Sweet. So think of it like rolling up a hill. So if I flipped this on its side, right, as we go from the positively charged plate, we're actually rolling up the hill to the negative charge. So our charge is going to it has some velocity here, but as it goes, it's going to get smaller until it gets to 0, and then it's going to roll back down the hill when this is negative. When it's positive, on the other hand, the hill flips. The hill flips. So we can erase this. Right. So this is like having the charge at the top, and it's going to have some velocity, but as it gets to the bottom, it's going to be even faster. Okay? So we can compare this to gravity in some parts of the Earth that we're familiar with. Don't let it being electricity confuse you. The main thing is that we are changing things based on the charge. When we flip the charge to its opposite sign, well, now we've kind of flipped everything around. The forces are flipped, the potential energy is flipped as well. All right.